Anatomy, musculoskeletal system. In this video, we will look at the different types of vertebrae that make up the spine. Let's start with the cervical vertebrae. There are 7 cervical vertebrae that make up the first part of the spine. What we're going to cover now is the structure of most of the cervical vertebrae, as the first 2, the atlas and the epistrophe, will have a rather different structure. First of all, the body is more quadrangular than cylindrical in shape, and the upper concavity is much more evident than the lower one, which instead almost does not exist. The arch is rather wide and will host a foramen that will be elliptical in shape, because at this level the nerve bundle that makes up the spinal cord is still very wide, because it has not yet begun to divide into the various peripheral nerves. The transverse process is one of the major differences with respect to the classic vertebrae, as it has an interior and posterior lamina united at the lateral level, delimiting a hole called transverse hole, which will be used for the passage of the vertebral vessels. The apophyseal masses or articular processes of this vertebra are located rather backward and laterally. Their surface tends to be flat and above all almost horizontal. Posteriorly, we find the closure of the arch and a spinous process, which is characteristically bifid at its ends, but it otherwise short and thin. In the centre, it is furrowed by a shower. The vertebral hole of these vertebrae is the largest among those of the other classes of vertebrae. Ultimately, these vertebrae are really characteristic not only for perforated transverse process or for the bifid spinous process, but also because their hole is the largest among all vertebrae, precisely because at this level the spinal cord bundle is quite a bit larger and decreases in size as you go down. Let's start by looking at some characteristic cervical vertebrae, starting with the very first one, the atlas. The atlas is a vertebra completely on its own, in that it lacks almost completely the body. This is because a large part of its structure constitutes an enormous foramen inside which the spinal cord passes as soon as it comes out of the skull, therefore at its maximum thickness. Its articular processes are very particular. At the bottom they are quite similar to those of other cervical vertebrae, and at the top they are condyle cavities for the articulation with the condyles of the occipital bone. The remnants of the body consist of the 2 arches of the atlas, the shorter anterior arch, which has the anterior tubercle, and the thicker posterior arch, which has a stubby posterior tubercle. The 2 lower articular facets are quite normal and will serve for articulation with the epistrophius, the second cervical vertebra. It can also be seen that the atlas is devoid of the spinous process. The epistrophe, also known as the axis, is the second cervical vertebra. Its shape is rather odd. It has a rather squat, quadrangular body that at the front and top has an apex or tooth of the epistrophe. Through this tooth, the atlo-axial joint will be formed, which will allow the rotation of the skull. Lateral to the tooth, there are 2 upper articular facets that are like those of all other cervical vertebrae. The transverse processes are perforated as in all other cervical vertebrae, but are slightly more stubby. Finally, there will be a spinous process that is a little less bifid than that of the later vertebrae. The vertebral foramen, the main one, is a little smaller in this vertebra than in the atlas and will allow the formation of what is a rudimentary body. The lower facet joints straddle this large ring. The thoracic vertebrae are completely different from the cervical vertebrae, and a sketch of their shape can be imagined by looking at the 7th cervical vertebra, which has features intermediate between the cervical vertebrae proper and the thoracic vertebrae proper. The thoracic ones increase in size as you progress downward. Their structure is quite simple and very similar to that of the vertebra in general. The following can be observed: a body, pedicles, apophyseal masses, arch closure, transverse lateral processes, and spinous process. What makes these vertebrae particular and characteristic with respect to all the others is the presence of facet joints for the ribs, which are located in different points. 2 we have in the posterior part of the upper margin of the body, another 2 in the posterior margin of the lower face of the body, and yet another 2 are present at the ends of the transverse processes. This is because each rib makes as many as 2 joints with the thoracic vertebrae, one at the level of the interface between the upper face of one body and the lower face of the other vertebra, and one at the level of the transverse process. The spinous process is directed obliquely downward, is not at all bifid, tends to be even unique and pointed. The vertebral hole is smaller and is roughly circular. Characteristic thoracic vertebrae are the first which does not have 2 articular facets on each side of the body, but a simple hollow in the center of the body with which alone articulates with the first rib. Other particular thoracic vertebrae are the last 3, which have a laminar and slender spinous process, similar to that of the lumbar vertebrae, being transitional vertebrae. In addition, in the 11th and 12th vertebrae, the transverse processes are not so developed, but are directed backward, are squat, and present 3 mammillonatures, of which one is called mammillary process, the other accessory process, and yet another anterior process. The lumbar vertebrae have the largest body. They also have a posterior structure that is small when compared to the body. The arch is rather narrow and roughly triangular in shape, much smaller than that of the thoracic vertebrae. In addition, the lateral processes this time take the name of costiform processes. Medially and above, compared to the costiform processes, we find the upper articular processes. On the other hand, to find the lower articular processes, we must proceed backwards on the vertebral laminae, which, stretching downwards, gives rise to the lower articular facets on the homonymous processes. The spinous process is rather stubby and laminar, usually has a ridge that ends in a tubercle, called mammillary process.
This video was created thanks to Anatomy Learning, an interesting free web app. The hyperlink can be found in the description. Instead, the text used for the concepts is Human Anatomy of Eddie Hermes. Thanks for watching.